An ellipse. An ellipse is an oval. Now you can have ovals that are sideways or horizontal major axis. The major axis is the axis of the longer stretch. So this is a horizontal major axis, basically stretches horizontally. And this one stretches vertically, which is a vertical major axis. So there's two ways of doing it. And the way you tell the difference is if you look at the equation, you have an x squared plus y squared equals 1. It always is in that form. So if you look at this one, and you have it, sorry, an a squared and a b squared. Anyways, if you look at this particular equation, look at the bigger, a squared is the largest denominator. You see how the largest denominator is under the x? So you see how it stretches along the x-axis? If you look at this one, see how the a squared's here? A squared is the largest denominator. Do you see how the a squared, the largest denominator, is under the y? So it's stretched along the y. That's kind of how you tell which way it's stretching. You look for the biggest denominator, and then what letter is it underneath. That tells you which way it's stretching because it's going to move farther in that direction. Now vertices. Your vertices are these 2 points right here. Those are your vertices. Now if I want to find those vertices, well, this would be 4, 0, and this would be negative 4, 0. Now how do I find those? Well, what you do is they're on the major axis, your vertices, and what you do is you just take a. See right here? It's the a value. Now, how do you find a? Well, this is a squared, so to find a, what you do is to get a, what you do is you basically square root the 16, which gives you 4. You square root the biggest denominator. And there's 2 of them, so I put plus or minus 4, 0, which is negative 4, 0 and 4, 0. Those are my 2 vertices right there. Okay. Next, I want to get my co-vertices. My co-vertices are on my minor axis, my smaller stretch, and these right here are my co-vertices. Those are co-vertices, and they're the b value. So b, well, b is going to be the square root of the smaller number. See, b squared. So you're going to square root 4, which in this situation is 2, and 0, positive, and negative 2. Meaning, isn't that 0, negative 2 and 0, positive 2? Doesn't that match up? Again, here matches those 2 green dots. So those are your vertices and co-vertices. Now your last piece is your foci. Inside of a ellipse are 2 foci. And your foci is your c value. And what you do to find c value is it's always c squared equals a squared minus b squared. And they're always on your major axis. So it's going to be on this major stretched axis. There's 2 dots somewhere in here. Now how do you find that? Well, we just go c squared is equal to, what's a squared? A squared was 16, remember the bigger denominator, minus b squared, which is a 4. And then we solve that. When I solve this, well, it looks like we got c squared is equal to, it looks like 12. And that right there, you would do is you square root both sides. So c is going to be the square root of 12, which is approximately somewhere between 4 and 3. So let's do it about 3.8. It's about the square root of 12. So c is equal to the square root of 12, which is about 3.8. So you go over here to your graph, and you go about 3.8. So your focal points are positive, negative, about 3.8, because the square root of 12 again is actually that's probably wrong. It's not 3.8. It's probably more like 3.5. Okay. Anyways, you plot those. Those are your 2 focal points. And let's just say positive and negative. Let's leave the square root of 12, comma 0. And those are your 2 focal points. Okay. One's 3.5 this way. One's about 3.5 that way. I just approximated that. I don't know exactly what that is. Anywho, number 2 here. As you can tell, your major axis is stretched this way because the bigger number is on the bottom here. So if we take, to find the vertices, it's always the a. So what we're going to do here again is we're going to square root 25. A is the square root of this, so that is 5. So a value is always right here, so it's 0, comma, positive negative 5, which if you look here, isn't that 0, comma, a negative 5 and a positive 5? Matches up. Okay, and then if we go to the next one, b, well, b is always going to be the square root of what? Now, your b value is going to be the square root of the smaller number, which is 3. Now, when I do this, the square, that's 3. So if you look at this graph, is that over 3 and over negative 3? So wouldn't that be a plus or minus 3 comma 0? Because it's on the x-axis. So those are my two values. And then the last one, like we said earlier, how do you find your foci? Well, it's always going to be c squared equals a squared, which is the bigger one, minus b squared, which is the smaller one, which looks like 16. So from there, isn't c going to be equal to the square root of 16? Because you square root this, which is 4. So this is going to be 0, comma, positive and negative 4. And the reason it's here in the y value, if you think about it, isn't it always on the major axis? So wouldn't this be down 4 and up 4? Aren't those the two focal points right here? So again, vertices are always your a values, the biggest stretch. The b values are your co-vertices, they're the smaller stretch, and the foci are your c value. They're always on your longer stretch, and you use this formula to find them.